This is a 2019 GCSE paper, paper 2, and we're looking at question 23 today. So it's one of the harder questions in the paper because it comes later in the paper. The diagram shows a parallelogram. It says the area of the parallelogram is greater than 15 centimeters squared. Show that 2x squared take away 21x plus 40 is less than 0. Now, when you work out the area of a parallelogram, try not to make the mistake of multiplying the slant height here by the width, because you won't get the area. The way that I would do it, there's more than one way of doing this question. That's usually the case with some of the harder questions. There's more than one strategy you can take. I'd probably split it down here. I get a right angle triangle, and then I can work out the perpendicular height, because I've got this slant height, and then because this is 150 and I've split it down the middle, if I know that this is 150, then I can work out the angle that is here. Once I get that angle, then I'll be able to find the perpendicular height of my parallelogram, and then the area. So what I'll do to do that is, I know that 150 degrees take away 90 degrees equals 60 degrees. That's one of the exact values that you need to know. So you need to know sine 30, cos 30, tan 30, sine 60, cos 60, and so on. Because I know that cos 60 is a half, I'll be able to work out, I don't even need a calculator. Even though this is a calculator paper, I could actually work it out without one. Because the slant height is 10 take away x, and this is our hypotenuse, we can use trig to work this, or simple trig to work out vertical height, or the perpendicular height of this triangle. So everyone should know SOHCAHTOA. Now, because this is 60, I know that cos 60 is equal to the adjacent side over the hypotenuse. Now, the slant height is the hypotenuse, and the perpendicular height is the adjacent side. So I know that my adjacent side can be put over 10 take away x. Because I know that cos 60 is a half, I can work out my adjacent side by multiplying out 10 take away x, and I thus get 5 take away half x, and that's the value of my adjacent side. So having found that, all I need to do now is I take this width of my parallelogram, and then I can come up with an expression for the area of the parallelogram by multiplying by this. So I can expand my brackets. So what I do is, first of all, write this out. It might be easier to swap your x terms around, because we usually, when we expand them, we usually have our x terms first. So I'll just rewrite that. So I'll have minus a half x plus 5 and 2x take away 1 over here. Now, we also are given this fact. So the area of the parallelogram is greater than 15 centimeters squared. So we can make that, we can write that inequality in. What I get is minus a half x plus 5, all in brackets, times 2x take away 1, close brackets, and then is greater than 15 centimeters. Once we do that, we can simply expand out our brackets. So we've got minus a half x times 2x, which is minus x squared. And then, so I'm just going to multiply that out. And then I'm going to multiply this out. So I've got minus a half x times minus 1. You get a negative number and a negative number. When you multiply them out, you get a positive. So you get plus half x. And then we have our middle bit to deal with. So we're going to do plus 5 times 2x. So that is plus 10x. And then we just need to multiply the final part. So 5 times minus 1, which is minus 5. And then we'll complete our inequality is greater than 15. So we've multiplied that out. We can see that we can bring together these terms. Now we've got a fraction here with our b term. So we've got a half x plus 10x. Now there's 2 halves in a whole, so you've got 10 wholes, and therefore you've got 21 over 2x. Take away 5 minus x squared is greater than 15. After that, I kind of want to get rid, just to make, because we need to show this. So in order to show that, I've noticed that there's no fractions in there. So I want to get rid of the fraction. So what I can do is I'll take the 2 at the bottom of the 21 over 2x, and then I can multiply each term by 2. So I'll get minus 2x squared plus 21x. Take away 10 is greater than 30. I also noticed that if I look at what I need to show, there's no negative coefficient here. So the x squared coefficient is positive. So what I can do there is I can times, and you might also notice that our inequality sign is the other way around. So what I can do is I can flip this sign by timesing by minus 1, and I can also make this term positive and this term positive. So if I times all of this by minus 1, I get 2x squared. That becomes minus 21x, and then plus 10. And then this inequality sign will flip around. I get minus 30 on this side. And because I need to show that it's plus 40, so here, all I need to do here is add 30 to each side, and I get 2x squared, take away 21x plus 40 is less than 0. So we've done the first part of the problem. Right, so after going through that little ordeal, you can go to question B. You've got to find a range of possible values of x. When you've got a quadratic, you usually, not all the time, but you usually get 2 solutions, because where it crosses the x-axis, these are called roots, or the solutions of the quadratic. And what it's asking you to find is, when it says the range of possible values, it's asking you to basically solve this inequality and find values of x that can satisfy the inequality. There's a number of strategies you can take to solve a quadratic, and all of them would work for this. You can factorize it, which is probably the easiest way, and that's the way I'll do. You can complete the square or use the formula. What I'm going to do is I'm going to factorize it. The way I'm going to do that is I'm going to take my quadratic, so 2x squared, take away 21x, plus 40 is less than 0. The general form of a quadratic is ax squared plus bx plus c. What I'm going to do is, because my a is greater than 1, it's 2, I can multiply my a term and my c term together, and then I can find my factors of the resulting product. 2 times 40 is 80. What I'm going to do is I'm going to think of some factors of 80 that also sum to give me minus 21. Obviously, because you've got a positive number here in 80, and you've got a negative number there, that tells me that I need 2 negative values. So I'm just going to list those out. So I've got minus 1 and minus 80, minus 2, minus 40, minus 4 and minus 20, minus 5 and minus 16, and I've got 10 as well. So minus 8 and minus 10. Of these values, you can see that there's only one that adds up to minus 21, and it's this set here. So what I'm going to do is I'm going to split this b term into 2 parts. I'm going to do 2x squared, and then I'm going to do minus 16x, and then minus 5x. And you can see together, if I add minus 16 and minus 5, I get minus 21. So I've split this up into 2 parts, and then plus 40. And for now, I'm just going to put equals 0. So once we've done that, I can factorize this set here, and then this set here. For this set, I know that I can factor 2 out and x. So 2x, and then I get x, take away 8. And then for this set, I should probably do this in different colors. So this set is here, and then I can factorize this set here. I've got minus 5x plus 40. I can factor out minus 5, and then I get x, take away 8. Because I know that if I times minus 5 by 8, I get plus 40 equals 0. From that, you'll notice that 2 of my brackets are the same. So I've got this bracket, I've got x minus 8 there, I've got x minus 8 there, and then I've got things around my brackets, so 2x and minus 5. So what I can do is I can place 2x minus 5 together in one set of brackets, and then I can put x minus 8 in another set of brackets and make them equal to 0. Then what I can do is I make each of these brackets equal to 0. So 2x minus 5 is equal to 0. I can make x minus 8 is equal to 0. And then I solve for x. So for the first one, I'll bring 5 to the other side. So I'll get 2x equals 5. And then I can divide that by 2. So I'll get x equals 5 over 2, which equals 2.5. And then for this one, I get x equals 8, because if I add 8 to both sides, I can get rid of that minus 8. So we've got our 2 solutions. So what that means is that if we were to draw this quadratic out, the point at which it will cross the x-axis will be 2.5 and 8. If I were to draw it like this, I'd have a point here which would be x equals 2.5, and I'd have a point here which was x equals 8. And basically it's saying values within this region satisfy the inequality. Now inequality can be written as 2.5 is less than x, and x is less than 8. So we've completed our little quadratic inequality question. I hope you've enjoyed sort of listening to my explanation. This is just how I solve it. There are a few other ways of doing it, but that's how I would approach this question. If you found this video useful, please like and subscribe.